welcome back. So this is the next video for the fifth lesson in Module 3 dealing with graphing the equations of quadratic functions, graphing quadratic functions. So here we have a word problem. A science class designed a ball launcher and tested it by shooting a tennis ball straight up from the top of a 15-story building. They determined that the motion of the ball could be described by the function negative 16t squared plus 144t plus 160, where t represents the time the ball is in the air in seconds, and h of t represents the height in feet of the ball above the ground at time t. Okay, so again, t is time the ball's in the air in seconds, h of t represents the height in feet above the ground. What's the maximum height of the ball? At what time will the ball hit the ground? Okay, so we're not asked to graph here necessarily, but we want to try to answer these questions. So with a graph, we can see the number of seconds it takes for the ball to reach its peak and how long it takes to hit the ground. How can factoring the expression help us graph this function? Well, what does factoring give us? Factoring gives us the factors of this quadratic function, which we can then use to find the zeros. Okay, so factoring allows us to find the zeros. And remember, once we have the zeros, we can use symmetry to find the vertex and any additional points. Oh, and I guess we kind of answered that question right up here too. Okay, so we want to graph the function. So let's go ahead and factor this thing. I'm going to go ahead and factor out the GCF of negative 16. I think we can factor out a negative 16 from all these things. Okay. So we get 9. And minus 10. Like so. This we can factor now. It's so strange. My pen is acting funny. Okay. We need two numbers to multiply negative 10 and add to make negative 9. So that's going to be t minus 10 and t plus 1. We'll set this equal to 0 too because we're trying to find the zeros. So we'll get t equals 10, t equals negative 1. Okay, and I'll go out here to get this thing graphed. There you go. I was going to say, hopefully it draws more there. Okay. So because we're looking at like time, and time should be mostly positive here, I'm going to go ahead and like put the x-axis, the y-axis like right here. Another thing I should have done too, actually, is put it down a little bit lower, because we're not going to talk about negative height either. So I can probably focus mostly on the first quadrant here. And so it'll be something like this. So let's see here. Negative 1 would be right there, that point, and then 10 will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right here. Okay, so then that distance is 11, right? From negative 1 to 10 is a distance of 11. So half of that would be 5.5. So 1, 2, 3, 4, 5 and a half, I guess, to be right here. So right here. Okay, there's where our vertex is going to be. So there's our axis of symmetry. Like so, and like so. Okay. So we already figure out what time the ball hits the ground. It's at time t equals 10, right? Because that's the the 0. Like that. Seconds. Ooh, ghosty. Okay, there we go. So let's get some more points. Let's find the y-intercept. So the y-intercept here, well, if you can imagine plugging 0 in for the t and 0 for the t there, it's just going to give us 160. So ooh, if we got to go up to 160 and even more so, maybe we should just go ahead and find the vertex too. So let's plug in 5.5 for t. Or not 5.5, sorry, it's actually 4.5. 1, 2, 3, 4.5. It was 5.5 units away, but we had to go, that gives us to an x-coordinate of 4.5. Okay, and then I'm just going to use a calculator for this. Okay, 484. So that's the highest we had to go, so goodness gracious. Maybe we count by like 20. Maybe I'll count by, yeah, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, let's just count by 20s. So, whoops. So 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. And so 484 is what we have to go up to. So 4.5, 484. So there would be 480. So 484 would be like right there. Okay, so there's that. Find the y-intercept we said was 160. So 100, 20, 40, 60, 160. And if we go 4.5 blocks, that'll get us to the axis symmetry. So 1/2 and 1, 2, 3, 4. There should be a point right here as well. Okay, so you can kind of like sketch the graph from here. Again, I don't know if it really makes sense to draw this portion of the graph right here since it's now negative time, but you know, we'll oh, that's strange. I got rid of the we'll go ahead and graph it just because. I'm going to do the same thing over here too. Okay, like that. Over what domain is the ball rising? So again here, it's rising from this on this section of the graph, right? But technically we probably should not include the negative part. So we'll say from this point right here, which is at what time? 0, up to this point, which is that 4.5. So from 0, and we'll include the 0 to 4.5. Actually, you know what? We should exclude the 0. When is the ball falling? Well, it starts falling at 4.5 and stops falling right here when it hits the ground, right? Because it's not falling anymore once it hits the ground. So that would be a time 10 there. Okay, using the graph, what's the maximum height the ball reaches? We found that already. That's the vertex. So 484 feet. Okay. All right, and we will stop the video there.